before the output layer or right before the software activations, it sort of generates this sort of probabilistic distribution of output tokens. I thought that was interesting in sort of them activating some features like code bug or even sort of they mention toxicity and other sort of ethical concerns, which seems to have an impact on the sort of how the output is generated. And it seems very experimental. Like the approach doesn't seem like it is, I mean, I think they also claim that it is quite in the early stages of understanding these LLMs. And I sort of like kind of always find it funny because it's not doesn't seem very unlike how I try to think of how I try to minimize uh, sort of hallucination in some thoughts or so on and so forth. Like try to refer, like make different connections and try to see if you can minimize that. And it seems that's the sort of uh, direction that this research is going. So I also was reminded of this other paper we read like some time ago on the why birds are smart in terms of brain imaging. Like my knowledge of brains and biology is very poor. And one thing I did remember from that paper though was that they found it difficult to sort of do imaging during the REM sleep and of these birds. And sort of they concluded saying uh, any information they can decipher from studying the neurons activations for these birds is sort of comes with that caveat that there is this huge part of brain activity that just couldn't mention. So I wonder what can be the sort of black might be blind spot in this approach, but it's interesting. And I'll pass it down to Venkat.
Actually, I'll pass to Shiva first and I'll go last.
Okay, yeah. Not much to add here. Maybe just a couple of things would be uh, the idea of dictionary learning that they mention. They also talk about it being like a fairly classical method in machine learning, and I've come across it in other contexts before. And I was just thinking about Venkat's prompt, relating to brain imaging, and it sounds like it's usually a very similar kind of technique where you're trying to learn, or trying to learn what each feature, like in the middle layer of these models, whatever kind of ML model it might be, trying to learn what each of these features might represent or be. Like, we've seen that in the past with like machine learning in images and videos, I think, where it used to be the case that you could look at like a visualization of like a particular feature and say, yeah, it's learning like a certain visual pattern, like lines or something more complex even, or like corners in like those classical sort of classification image problems that we used to see a while back before LLM sort of took over. So, and I also remember that this same method of like, I guess, dictionary learning, I think in this context, it seems to be a very engineering term. And I know like it's sort of like a certain method that is also used in like signal recovery and like, trying to extract like signals in like fMRI signals, for instance. And they use a fairly similar sort of uh, technique. I don't know the details, but uh, that's one. And uh, it's the other thing, totally unrelated, is this whole idea of like trying to amplify like certain features and see if uh, it might how the model's outputs might change or react. Kind of reminded me of this novel I've read a while back. I think it's Flowers of Algernon. I don't know if anyone else is familiar with it, where there is just this one guy who has like a brain surgery, who sort of has a low IQ, goes through a brain surgical sort of operation, and then eventually over time his brain functions drastically improve. He goes from like being like this completely idiot of sorts to one of the smartest people in the world, and so on. It's a fairly classical sci-fi story, and I thought that was pretty interesting as well. It just the way that they're prodding at these different features to get at like certain um, or get at certain outputs. It sort of just reminded me of that novel, but Yeah, I'll stop there. I don't have much to add. I think Ben sort of also talked a lot about what I was thinking. And I'll pass it on to Jenna.
I think Jenna and Anuraj are both on mute today. So I'll go and then if they are able to unmute, they can speak. Yeah. So the first question that occurred to me is the one I posted, which is it's not clear to me how they're like going from neuron space to feature space. So if you have n neurons and each can be either on or off, that's conceptually 2 to the power n, so the power set. And that's that many feature vectors. And that's a huge space to traverse. And I guess learning that space is a bit like, I don't know, you give it a bunch of prompts relating to the Golden Gate Bridge, and you roughly learn the direction that vector goes in. You do some thresholding, get rid of like the noise in the signal, and you get a rough direction in that space of what the Golden Gate Bridge looks like. And yeah, I too really sort of locked onto that second part of the paper, which is what happens when you latch that vector in that direction. It was not quite clear to me what they meant by doing that. Is it locked to, like, have you maxed out Golden Gate Bridge when you're prompting it for completely unrelated things? Like, maybe you're prompting it about US presidents, but with Golden Gate locked on max, does it randomly bring the Golden Gate Bridge into discussions of American presidents or other unrelated topics? So that part was not super clear to me, but that's also the most interesting because I think lots of creative stuff can happen there, as in like you can lock certain features you want. Like say you want really surreal kind of like storytelling. So you might lock Golden Gate Bridge on high and tell it to rewrite Shakespeare's play with changes, right? And now it could be that maybe Shakespeare's plays get all rewritten with a bridge being an important part of the plot for no good reason. And that might be funny. It might be a good new kind of genre. So that use case, I'm surprised they didn't go down that. They seemed mainly interested in basically model explainability problems and also safety and governance problems, which I both kind of find a little bit boring. They're like Anthropic, of course, is like famous for forking from OpenAI with like strong safety concerns. But it's like they're ignoring the most interesting parts of what they've done here and gone to the kind of boring stuff. But yeah, the interesting stuff there is what creative new types of output can you do once you've identified a bunch of features and have like an arbitrary ability to lock different features in different places while processing generic kinds of input. And this is also like it's not just creativity. This is also where you can create basically madness. So like I guess a classical sort of like joke about people in asylums is they go around imagining they're Napoleon. And this model went around imagining it was the Golden Gate Bridge. And it kind of makes sense that happens. That normally if you asked it, who are you? It says I'm an AI model, I'm not a person or whatever. But once you've logged Golden Gate Bridge to a really high value, every answer it's going to like steer towards Golden Gate Bridge. So it says I'm the Golden Gate Bridge. So that result is not surprising, but it suggests that we can generate interesting kinds of madness. We can like fill an asylum with mad LLMs, and that might be funny. And the other line of thought I was thinking was the difference between this way of imaging the brain of an LLM versus imaging a human brain is, I think fMRI type imaging, since they take relatively coarse snapshots of the brain, which are more like, it's not all the neurons are at 0 or 1, but clusters of them. So if a part of the brain lights up, you kind of know that all the neurons in that area are roughly lit up. So you kind of get a very averaged sense of what's going on here. So this is like very precise. And what we do with fMRI is a blurred version of that. But the blurring seems to be interesting because typically with fMRI, you get like vaguer results, like this part of the brain is involved in decision making, or that part of the brain is involved in long-term memories. You get like broad sort of like macroeconomic neural data, and that actually seems kind of useful because this is a lot of detail. If you have to go around like understanding and biasing models at the level of like specific concepts like Golden Gate Bridge, this is kind of like too detailed a technology to be useful. But on the other hand, if there was a knob you could turn where you tell it to bring up some bridge, no matter what the topic is, bring up a bridge. So not just Golden Gate Bridge, but maybe if you're talking about, I don't know, some topic in Germany, it'll bring up a German bridge. So it would be useful, I think, to have like an fMRI type coarse imaging capability. And of course, the manipulation capability is something we don't have with the human brain. Like we can insert electrodes and activate maybe dozens of neurons at a time. It's basically impossible to activate a single neuron. And as far as I know, like even with weird sci-fi concepts like neural lace, you can't activate an entire pattern of neurons. So this, what you can do with this model, which is activate an entire feature, which I assume corresponds to like locking lots of weights at high values. Nothing like that is possible in the brain. So this is kind of like an unprecedented new capability. So yeah, lots of interesting stuff. So yeah, floor's open. Anuraj and Jenna, if you want to like chime in, you can now. Or anyone else, the floor is open. More comments? All right. So nobody has second order thoughts. I guess this was a difficult, long read. But yeah, if nobody else has thoughts, we can call it early and give you guys back 15 minutes of your time. Right, going what? Oh, Shiva is speaking, yeah?
No, I was just saying, all right.
All right, then. We'll give you guys back 15 minutes of time. So see you next week. And that's Anant's reading, I believe. All right.